Hi guys! Today I am going to be going over ratios and proportions. So we're going to be doing a different standard today. This is standard that, okay? Saying it's not going to do me any good. Our objective would be today I will find equivalent ratios, but before we even find equivalent ratios, I just want our goal to be to understand what a ratio even represents. So, a ratio, like what is a ratio? A ratio is essentially any relationship between two numbers, okay? So, let me just think of an easy one off the top of my hand. Okay, that works perfectly. Okay, so for every one palm I have 5 fingers, or for every one hand I have 5 fingers. Basically, my relationship between palms to fingers or hands to fingers is 1 to 5, right? So if I have 2 hands, I'm just doubling that, but I'm still going to have the same basic ratio. It's still going to be 1 palm for every 5 fingers, correct? Yes. Okay, for an example, I'm going to use the ratio of green apples to red apples is 2 to 3. So what I'm saying is if I bought a basket of apples, this is my beautiful basket of apples, right? In each basket, there are 2 green apples because green comes first in my problem. 2 comes first in my numbers, so those 2 are matched up with each other. So order totally matters when I'm talking about ratios. Whatever word I say first or whatever quantity I'm talking about first, those match together. So green, there's 2. Beautiful. Those are my apples. And red apples, there are 3. Correct? So for every basket, essentially, there's going to be 2 green apples and 3 red apples. Does that mean that I can only ever get 2 green apples? No. It does not mean that, right? If I wanted to get more green apples, I would just have to buy another basket. But if I bought another basket, if they're selling these as a ratio, right, if this is a ratio, that means that this stays the same. This basic ratio stays the same. So then my next basket's still going to have 2 green apples and 3 red apples. Correct? Okay, so if I want to talk about these apples as a ratio, I want to say that the ratio of green apples to blue apples, where are blue apples? The ratio of green apples to red apples is 2 to 3. I wrote that in my problem. A lot of times you're going to see ratios written like this. 2, 2, 3. You can also see it written out 2, 2, 3. But most commonly you're going to see it as a fraction. 2 to 3 like that. In my examples, I almost exclusively use fractions because I think it makes it a heck of a lot easier. So for the sake of this lesson, I'm going to stick pretty much almost always with fraction form. But you still do need to know that these 2 things represent ratios as well. So let's say I wanted to get 8 green apples. I need 8 green apples, but these only come in packs of 5, right? These only come in packs of 2 green apples with 3 red apples. I can't just pick out my green apples. So if I wanted to get 8 green apples, I'm going to basically just keep drawing this until I find out that I have 8. Already I have 4. That was beautiful. I'm going to keep drawing my baskets just so I don't have to keep switching colors. 5, 6, 7, 8. Because I know that I have to keep 3 red apples for every 2 green apples. So now I have 8 green apples, right? And how many red apples do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in that situation, I have too many markers. I have 8 green apples for every 12 red apples. That is the exact same as this, 2/3. They're just, this is a simplified version. So if I were to go from 8 to 2, I would divide by 4. And if I were to divide by 4, I'd get the same answer. They're the same ratio, for lack of a better term. This is just the more simplified version of it. But when we get these kinds of problems, you can either draw out the model like this, but I'm going to be honest with you, it takes kind of a lot of time. This is, knowing how to do this is a 6th grade standard, but there's another way that you can do this. So when you see these questions, you can answer a little bit more quickly. This is kind of the trick, and my class, you guys have seen this before, but I think it's okay to know this trick as long as you understand why this trick works, okay? So, I am messing this up. I should not have erased that. Pretend that we still know that. The ratio of green apples to red apples. Ratio of green to red is 2 to 3. like I said, I am going to use, this is a fraction, but I always like to label my fractions. I don't want to forget what that 2 represents, so I'm going to say 2 green for every 3 red. Okay? Now, let's just say that I get a problem that says, all right, I have 36 red apples. Okay? Instead of actually drawing out that diagram and drawing like way too many baskets, which would take a heck of a lot of time, I'm going to set this up as an equivalent ratio. Okay? So we know that if I'm keeping my ratio the same, I can't just pick and choose out of my apples. I have to get 2 green apples for every 3 red apples because that's how they're selling these baskets. And they're saying that I'm getting 36 red apples is what I wanted. Yes. Now I want to figure out how many green apples would I be getting. So in order to do this, there are 2 separate ways that you can do this. We can either see what goes on to go from here to here. So what do I do to 3 to get to 36? And I can think about that and I can say, all right, well, I would multiply 3. And if I multiply that by 12, I could get to 36. And then I can do that to the top as well. That will work sometimes. Okay. The reason that I don't like to teach this trick, like of just multiplying across, is because it doesn't work all the time. And I don't want you guys to get an example where you have to multiply by like 1.25 and you don't know how to do that. And then you're completely thrown off. So I'm going to show you guys a way that works every single time, no matter what. It will always work, okay? And that is to multiply across whatever's across from each other or whatever's diagonal from each other and then divide by what's left. If you do it this way, it will always work, and it will help you if there are ever problems with decimals, which you will see, okay? You're going to see that. So I would get in the habit of using this because models, not always helpful. Multiplying, just like seeing what happens, not always helpful. Multiplying across and dividing by what's left, always, always, always works. So get into this habit, okay? This is the 7th grade standard, I want to say. But if you're given this kind of problem on any test, or if you need to know it in 7th grade, this will still work. This will still get you the same answer. And this is always an awesome strategy that you can use to check your work just in case. All right, so I'm multiplying across. So I have 36 times 2 is across from each other. 6 times 2 is 12. 2 times 3 is 6 plus 1 is 7. That's not my answer. And I can know that that's not my final answer because if I'm looking at that and I'm saying there's a smaller number on top and a bigger number on bottom, if I put 72 on top, that doesn't make sense. That wouldn't make an equivalent ratio, right? Because I still have to divide by what's left. I still have to do 72 divided by whatever number I have left over, which is that 3. So 72 divided by 3. 3 can go into 7 2 times. 3 times 2, 6. 7 minus 6 is 1. Bring down that to 2. 3 can go into 12 4 times. 3 times 4 is 12. 12 minus 12 is 0. So my answer, my final answer, is 24 green apples. Okay, so realistically, ratios are one of those things that you're almost always going to be seeing in word problems. So I want to get used to practicing how to even set up a ratio in word problems. So I'm going to give you an example word problem, okay? I go to Costco. I'm not going to go right now. That place is crazy right now. But say one day I decide, oh no, he's coming. Hi, Chompy. Say one day I want to go to Costco. And let's say that one roll of toilet paper, let's just stick with a theme here. One roll of toilet paper costs, this is outrageous, $3. One roll of toilet paper costs $3. So my first thing that I'm going to do is I'm going to see, what am I even comparing here? I'm comparing rolls of toilet paper and money. Those are my 2 quantities. Those are my 2 units. Those are the 2 things that I'm talking about, right? So if I have one roll of toilet paper is $3, I'm going to set that up as a fraction. So one roll is $3. Yes? Now let's just say we have $24 in my bank account and I want to spend it all on toilet paper. I'm just throwing all my money into toilet paper, all right? It's the end of the world. We need toilet paper. Let's get toilet paper. So in order to set this up, I want to think, okay, they also told me that I have $24. I want to like keep that 24. I have $24. Okay, so I'm going to set this up as 2 fractions that are equivalent to each other, okay? And when I say that I have $24, I want to sit here and I want to think, okay, I have $24. That's another value that they're giving me, and it's money. When I'm making equivalent ratios, I want to keep the values that have the same unit next to each other. So what I mean by that is I want to keep toilet paper next to toilet paper, and I want to keep money next to money. So because of that, I want to put my $24 on the bottom, okay? And now this step we know how to do. We multiply across and we divide by what's left. So I'm going to multiply one roll times $24 is 24, divided by 3, because remember I still have to do that last step, is 8. So that means that with my money, I can buy 8 rolls of toilet paper. Okay, I want to explain my reasoning for making up this next problem. In a pack of Sour Patch Kids, there's 5 colors, I think. I'm pretty sure. Don't check this, okay? But I'm pretty sure there's red, blue, green, yellow, and orange. I think that those are the only Sour Patch flavor colors. In my personal opinion, the only good flavors are red, green, and blue. I said it. Yellow and orange aren't good Sour Patch flavors. That was my inspiration for this problem, okay? I just want you to know. So, it's kind of hard to read, but I wanted you guys to pause this and try to set this up before I solved it with you. But I'm going to read it just in case to make it a little bit easier. So the ratio of good Sour Patch flavors to bad Sour Patch flavors is 3-2, which means that there are 3 good, because good comes first, right? To 2 bad. I'm going to underline these. Bad comes second. 2 comes second in that problem. So that's how I know that that is an awful color choice. Green and blue look way too similar. What if I do that? Make it a little bit easier. I don't know where I was going, but I'm just going to continue this. If I have 144 good flavors, how many bad flavors do I have? Step 1, I want you to set this up as a fraction. Do it. Pause. Do that right now. Welcome. I hope you set that up as a fraction, and I hope your fraction looked like this, and I hope it's labeled. If it's not, pause it right now and label it. All right, so we have 3 good to 2 bad. Is that too low? No, you can still read that. Okay, now I want to see what other information does my problem give me. My problem says if I have 144 good flavors. I told you this. My same units want to stick together. So in my original problem, I put 3 good on top, okay? So I'm saying 144 good. Good wants to stay with good. Good guys want to stay with the good guys. So I have to put this 144 good flavors on top, because they want to stick together. They have to stay next to each other in order to solve this problem. Okay, now in order to find how many bad flavors there are, I can see what's going on from 3 to 144, which you probably don't know that off the top of your head, which is why I'm telling you the best way to solve this is to multiply whatever is diagonal from each other, so 2 and 144, and then divide by what's left. So multiply across, divide by what's left. So first step, I want you to multiply 144 times 2. Pause, do that now. Welcome back. I hope you got 144 times 2 is 288. Now, is that my answer? No. Okay, that's not my answer. We still have to pause. We have to divide by what's left. Pause and do that if you didn't do that already. All right, welcome back. So I'm going to actually work out this part of the problem. So 288, this does not look very good. Divided by that 3 that's left over. 3 can't go into 2, but 3 can go into 28. 3 can go into 28 9 times. 3 times 9 is 27. 3 can go into 18 6 times. 3 times 6 is 18. But that didn't look very good. So my answer is 96. That looks really funky. Bad flavors. So that means that if I needed to find 144 good flavors of Sour Patch Kids, I'm going to get those 96 bad with those good too, because they are a ratio and they stick together, okay? You can't go sort out and just pick out the good ones. That's against the rules. You got to buy the whole pack, okay? Okay, so I said that a fraction always works, and I stand by that. A fraction always works, but sometimes it might be hard to remember what numbers to put in the fraction. So the only time when I would not encourage using a fraction is if you see these 2 words, okay? More or total. if you see either of these words in a fraction, that is a worst rectangle. If you see either of those words in a ratio problem, I would suggest you use a tape diagram. When I first heard the word tape diagram, I was like, oh, I don't want to do that. Okay, but hear me out here. I actually kind of love tape diagrams for these because I think that when you see these two words, tape diagrams make it way easier, okay? So this is kind of its whole mini lesson within a lesson. So bear with me, all right? So let's say, same thing. Let's use the same example. The ratio, I've got to come over here to write this. The ratio, I'm not going to write out the whole thing because we've already discussed this. The ratio of good, we're talking about Sour Patch Kids here. Good to bad is 3 to 2. If there are 16 more good Sour Patch Kids than bad Sour Patch Kids, how many good and bad I wrote kids, I mean Sour Patch Kids are there? That's so much funnier. I'm gonna leave that. Okay, so tape diagrams are a fifth, not even fifth. Tape diagrams have been seen like throughout the history of your education thus far. Okay, so you've probably seen tape diagrams, but if you don't remember, because every year kids come into my school, into my classroom, and they tell me that they've never been taught it, even though I know that they've been taught it. You have been taught it. I'm still gonna do a refresher course because I think that that's gonna be helpful. Okay, so I said good comes first. What number comes first in my ratio? 3. So 3 matches with good. These are totally different colors, so hopefully this is easier. Bad comes second, 2. So if I were to write this as a tape diagram, how I would do this is I would write good. I gotta go back over here. Oh my goodness. Good. Bad. And I would draw boxes that correlate with these ratios. So how many good Sour Patch Kids are there? 3. So I would draw 3 boxes. And how many bad Sour Patch Kids are there? There's 2 boxes. Okay? But I said that there are 16 more. Take a second and think about what that word means. Okay? Does that mean 16 good? No, I would have said good. Does that mean 16 bad? Nope. Does that mean 16 total? No, that's just saying 16 more. So I want to look at these boxes and I want to say, how many more boxes are there for good than there are for bad? I'm giving you a second to think about it, okay? If you want to pause and think about it, that's good. A strategy that I use in my class is that I like to make matches so that I can find who doesn't have a match, that's who's left over. So this guy matches with this guy matches with this guy doesn't have a match, he's all alone, right? I can only match like up and down. I can't be like, okay? This represents my 16 more. This is how many more boxes. I have 1 more box for good than I do for bad. So this represents those 16 more. Okay, so I want you guys to think about this for a second. If I have 16, that has to go evenly into only 1 box. Okay, what's gonna go in that box? 16 has to be divided evenly to 1. What is it? 16, yes, it's 16. If I have to put all 16 into 1 box, the only 16 divided by 1 is 16. When I'm talking about these tape diagrams, if it's in this box, it has to be in all the boxes. All the boxes have to be the same thing. So 16 goes into all of those boxes. So I probably should have used a friendlier number here, so I'm really sorry, but I'll use another example where it's a slightly friendlier number next. Okay, so if I have 3 boxes of 16, how many good Sour Patch Kids do I have? I would do that as 16 times 3, but you could also do 16 plus 16 plus 16. So I'm just going to write 16 times 3. 3 times 6 is 18. 3 times 1 is 3 plus 1 is 4. So I have 48 good Sour Patch Kids. And if I have 2 boxes of 16 for bad. I have 16 plus 16 or 16 times 2, which is, pause it, solve it. Welcome back, it's 32. 32 bad. And I'm asking how many good and bad kids are there. So I have 48 good Sour Patch Kids and 32 bad flavors of Sour Patch Kids. Another way that they could also ask you that is how many are there total. If I wanted to find total, I would just add those up, right? So 48 plus 32. We should be able to answer all of these questions. So that is an awful 0. I have 80 total Sour Patch Kids. Okay, so I explained why more works, but now I still have to explain why total works. And then this is the one I'm going to use a friendlier number with. Be right back. Okay, so I thought of a better way to write Sour Patch Kids instead of just writing kids, because I feel like maybe if somebody like clicked on this video and then paused it and they're like, why are they doing a ratio of good kids to bad kids? That doesn't seem very ethical. So instead of saying kids, we're gonna say SPK, Sour Patch Kids. Makes sense, right? So SPK stands for Sour Patch Kids, all right? So the ratio of good Sour Patch Kids to bad Sour Patch Kids, the same as we've been using this whole time, it's 3 to 2. If there are 45 Sour Patch Kids total, then how many good Sour Patch Kids are there and how many bad Sour Patch Kids are there? So, in order to solve this, I know that I see the word total, so I want to use a tape diagram. If it's even helpful, I'm going to make that look like a very wonky, bad, terrible tape diagram. Just remember those words more and total mean that I want to use a tape diagram, okay? Those are the only times when I want to use a tape diagram. Every other time I want to use a fraction. Okay, but you could also use a tape diagram if you just like tape diagrams better. Like I have said to you, whatever strategy works for you, use that strategy. Do it. I appreciate that. We all learn in our own ways. Embrace it. Okay, so I'm going to still use my tape diagram, and I'm going to use the same amount of boxes, right? The ratio of good to bad is still 3 to 2, so good. I'm going to draw 3 boxes. Bad, I'm going to draw 2 boxes. Okay, but now I'm saying that there's 45 Sour Patch Kids total. Am I saying that there's 45 good? No. Am I saying that there's 45 bad? No. I'm saying there's 45 total. How many total boxes do I have on there? Think about what you know about that word total, and I want you to count those boxes and see how many boxes there are. How many total boxes have I drawn on this thing? 5. I've drawn 5 boxes. 1, 2, 3, 4, 5, right? Total implies just counting everything up. So I have 45 total Sour Patch Kids. Both good and bad, I got 45. So if this 45 now has to be split evenly into those 5 boxes, 45 is split, divide, into 5 boxes, what's going to go in each box? Pause, think about it. Welcome back. 9. So remember, if 9 goes in one box, 9 has to go into all the boxes. 9, 9, 9, 9, 9. So how many bad Sour Patch Kids are there? If I have 2 boxes of 9, I have 18, right? 9 times 2, or 9 plus 9, 18. If I have 3 boxes of 9 for good, I have 27. And I would even go through and check my work and see, okay, if I have 27 good plus 18 bad, does that equal that total that they're telling me, 45? Well, 7 plus 8 is 15. 2 plus 1 plus 1 is 4. So yeah, that works, right? So this is why you might want to use a tape diagram to find out more or total, because a lot of times it's easier to visualize that. But again, whatever works for you, fractions, tape diagrams, beautiful. Use it. Whatever strategy you like better. Okay, I'm going to do another example problem here. So let's say the ratio of dogs to cats. Dogs to cats. Oh my goodness gracious. I hope I'm not being graded on my handwriting. Dogs to cats is 1 to 5. Okay? Not a good sentence. I don't know why I put a period at the end of that. The ratio of dogs to cats is 1 to 5. So, which one comes first in my sentence? Dogs. Which one comes first in my ratio? 1. So that means that there's 1 dog for every 5 cats. Order matters, remember that. So if I were to say that there are 8 dogs, okay, so the ratio of dogs to cats is 1 to 5, and there are 8 dogs total. How many cats are there? So now we know that there's 8 dogs. First things first, I want to set this up as a fraction. Like I said, I don't see the word more, and I don't see the word total. So I personally prefer to use a fraction to do this. So, one dog, yes, one dog to every 5 cats. And the other piece of information this problem is telling me is 8 dogs. I know dogs have to stick with dogs. It's got to stick together, dog. So dogs is going up here because they got to stay together. Dogs are with my dogs. And now to solve this, I multiply across and I divide by what's left. So those are the only two things diagonal from each other. 8 times 5 is 40. Divided by 1 is still 40. So that means we have 40 cats. Yes? Okay, so I don't actually know if there is, that was not a sentence. There are worksheets to go over these. So I'm going to do something else instead. I am going to write down sample problems in the description box. And so I'm going to like do 1, 2, 3, 4, 5. And then I'm going to like do little spaces. And then I'm going to draw an answer key. I don't want you to look at the answer key until after you solve the problem. That's how that works, okay? So like I want you to try to solve them first. And then I want you to look at the answer key and I want you to check your answers. Got it? Okay. And if you have any questions, ask me. Leave it in the comment section, okay? I think that this is kind of our this is a very, very, very basic version of ratios. I'll go on to rates next. Very similar to ratios. If you got ratios, you got rates. And then percents. And again, if you've got rates or if you got ratios, you got percents too. These are all very interconnected and we're going to use the same strategy to solve all of them. So as long as you're comfortable with this multiplying across and divide by what's left, the next few lessons should be easy. All right, let me know how you guys do, any questions or anything like that. See you guys later. Bye.